Hello guys, welcome everyone. In this video, we are going to learn Fanuc, spindle positioning and spindle encoder is nothing but types of sensor used to detect the spindle position. Okay, and also we are going to know about what is spindle orientation and how it is performed in CNC. Let's get into the video. Okay, first of all, we need to know what is spindle position. We are going to troubleshoot the machine. So someone is saying the spindle is not getting orientation. Okay, is not orientating properly. So that time you should know what is orientation, then only you will be able to uh, troubleshoot the machine efficiently, otherwise you cannot. Okay, so before that we need to know one thing. Usually we will use the spindle for only speed control, not for position. Maybe in some special cases we need to control the spindle position also. Okay, for example, we can take the machining center. In that machining center, we have the ATC's automatic tool change. Okay, so in the tool change, we need to perform exact tool changing process. For example, I'm just going to call number 2, second tool. So that time spindle should be in position. Otherwise, tool may be dropped. Otherwise, we may get accident between the ATC. Okay, so that's why we need to put the spindle in the exact position, a specific position. So for that purpose we need to control the spindle's position, right? Okay, so this is what we usually call the spindle orientation function. If you want to change your tool, so that time we need to make the spindle as in orientation condition, otherwise we cannot tool change. If we tool change without the orientation, tool will drop or some other accident may happen. Okay, so this is the spindle orientation function. So the next, how the spindle orientation is working. See, the spindle orientation function is that the NC sends an orientation command to stop the spindle at a certain position through the one turn signal on the position sensor on the spindle. Okay, and provide a certain holding torque to the servo motor position loop. So I'll explain what is servo motor position loop later, maybe the next video. So but in this video, see, NC sends an orientation command to the stop the spindle at a certain position through the one turn signal. What is one turn signal? Okay, so if you want to orientation your spindle, so you will press the orientation button on your machine. So that time NC will send the one turn signal to the position sensor. Okay, so in position sensor we have the one turn tooth. So that tooth will be sensed and our position, our spindle position will be stopped at the specific position. So that is the spindle orientation. See, this is the types of spindle sensors we are using to detect the position. First one is MZI. So this is nothing but the gear tooth structure output is a positive rotating wave. It will give the positive rotating wave output. So this is MZI sensor, and next one is BZI sensor. So this is the basic representation of the sensor. So you can see here cables, connectors, and shaft and sensor mounting surface. So these are all the parts involved with the BZI sensor or spindle sensor. Okay, so this is a motor shaft. So in this motor shaft we will mount a sensor mounting surface first. So in that mounting surface we will able to fix the sensor ring on the sensor mounting surface. So once you mount the sensor surface, sensor ring, so after that you should mount the sensor head. It will give the signal to the controller. Okay, this is the basic outlook of the BZI sensor or MZI sensor, like that. Okay, so when you open the back cover of the spindle, then you may able to find this one. Okay, the gear tooth structure output is positive rotating wave. In this types of sensor also we are getting positive rotating wave, and its feedback signal is output through a dedicated preamplifier. So sensor is nothing but a preamplifier. So through this preamplifier we are getting the signal, feedback signal to the controller. We are sending the signal to the controller. Okay, see, it is generally used on the Fanuc built-in spindle or can be assembled on the spindle head. Normally it will comes with a built-in option, otherwise we can assemble on the spindle head. So this is the spindle head. On the shaft we can mount the sensor mounting surface. On the mounting surface we will mount sensor ring and sensor head. So using this we will get the signal. This is a preamplifier. Okay, See, here we have the sensor ring. In sensor ring we have two phases. So phase Z signal generation section, and another one is phase AB signal generation section. Okay, so let's see why we are using phase Z and phase AB. Okay, so first we have the sensing head. Sensing head. The work of the sensing head is sensing the speed signal and the one-turn signal. Pay attention to the sensing distance with the gear ring. It is sensing the teeth and slots and everything, and it will give the signal to the controller. Okay, so the next one is one-turn signal ring. What is this one-turn signal ring? Okay, there is one tooth in one turn which generates a one-turn signal. You can see one tooth here in phase Z. So this is the one-turn signal ring. If you give the spindle orientation, then the preamplifier sensor head detect the one tooth, one rotation. So we can set according our requirement. We can set our position according to the requirement record position. So we can set this phase Z. So this is the spindle orientation ring, or you can call as a one-turn signal ring. So if you give a one-turn signal, then spindle will rotate and stops at this tooth. Okay, so now our spindle is in orientation position. So this is how spindle orientation happening inside the CNC. Okay, next one is A and B phase tooth ring. So this one is to generate AB phase pulse. There are 128, 256, 384 and 512 teeth revolution in a circle. So this is nothing but revolutions. Okay, per revolution. Okay, per revolution we will have 512 or 384 or 256 or 128. So this is BZI sensor. This is overlook. And the next one is CZI sensor. The gear tool structure is basically the same as BZI, but number of teeth is different. See here we are getting 512 and 1024 up to 1024 teeth per revolution. And next one is position encoder. This is digital signal output. We can get 1024 pulses per revolution. So if you do one revolution, and this encoder will send a 1024 pulses. According to the pulses, you can calculate, you can control your spindle position. And as precision encoder, this encoder is sending the analog signal output. So see, this is a sine wave, and this one is square wave. In this also, we are getting 1024 teeth per revolution, not pulses. And next one is proximity switch. See, the spindle is positioned by the proximity switch on the spindle and the MI sensor on the spindle motor. So proximity switch, this is also used for the spindle orientation. Like here we have seen the phase is at one tooth. So like that we can position the spindle using proximity switch. And magnetic sensor positioning also, but it is very higher cost. In this arrangement we have a magnet, probe and preamplifier. So using this we can able to positioning the spindle. Next one is mechanical positioning. So in this method we will use the external positioning pin to stop the spindle at the specified position. So these are the types of positioning methods of the spindle. And next one is connection example of the position sensor. So this one is the connection of MZI sensor by the spindle motor with built-in MZI sensor is used. So see, this is the MZI sensor inbuilt in the spindle motor, directly connected or connected with a gear or timing belt at a ratio of 1:1. So in JY2 we will get the signals from the MZI because it is built-in. The next one is connection of BZI and CZI when the separate type BZI sensor or separate type CZI sensor used. So that time the sample system configuration of the Fanuc spindle. See, here we are getting the JYA2 and here we are giving external signal JYA4 to the drive. See, BZI or CZI. It's separately connected on the timing belt side. See, here we have. And next one is connection of position encoder. When the alpha position encoder is used, alpha position coder. So this is a SPM type A. In type A, we will connect this position coder into JOI-A3 connector. But if we use alpha position coder, yes, that means we should connect this coder into JOI-A4 because this one is SPM type B. If you want to know about more details, then go to online and type the manuals, type A and type B, search it on and download it and get studied about this one, type A and type B. So this is the connection of when we use alpha position coder and alpha position coder S. Okay, so the next one is proximity switch connection. When the external one rotation signal is used. See, one rotation signal is a one turn signal. Sometimes we will call it as a one turn signal. So this one is used to achieve the spindle orientation. So we will externally connect the one proximity switch. So using the switch, we will stop the spindle in the orientation position. Okay guys, so these are all the methods and types of sensors and what is spindle positioning and how can we do that in CNC machine. So these things we have learned in this video. So in the next video, I'll explain a lot of interesting topics about Fanuc spindle and servo. Okay guys, thanks for watching. If you really like this video, then share this video with your friends.